Today's objective is to understand dilations. What is a dilation and how do we create a dilation? To start, let's go ahead and look at some definitions. Number one, a dilation. It is a transformation that changes the size but not the shape of a figure. In order to have a dilation, there has to be a scale factor. The definition of scale factor, it is the ratio of the dilated image to the original. In other words, you're going to have an image that is larger or smaller based on a scale factor. You may have an object that is twice as big or 3 times as big or maybe even smaller than the original, such as half. Those are all scale factors, 2, 3, or half. Let's look at some examples that I've drawn here of a dilation. On this grid right here, I've plotted 3 points and connected them to make a right triangle with this little green one here. The measurements, the units on this side is 3 units here, 4 units this way. So we know from the Pythagorean theorem that we have a 3, 4, 5 right triangle. Based on these ordered pairs, I have dilated the image by a scale factor of 2 and created this red triangle, which is now 6, 8, 10. Okay, I will show you in a moment how to use the ordered pairs to create the dilation, but let's just look at it right here. You see the green triangle is a 3, 4, 5. If we multiply everything by 2, 3 times 2 becomes 6, 4 times 2 becomes 8, and 5 times 2 becomes 10. So the 3, 4, 5 became a 6, 8, 10 triangle. This one has been dilated by a scale factor of 2. Let's look at the steps of how to actually create a dilation. Step number 1. If the origin, which is the ordered pair 0, 0, is the center of dilation, multiply the ordered pair of the vertices by the scale factor. We'll look at that in one moment. Step number 2, please understand that A with this hashtag is used to identify the ordered pair of the vertices of the dilation or of the enlarged or reduced image. Down here I have a square in blue. This is square ABCD. I've dilated that square, and now in green we have square ABCD, but it's been identified as a dilation with these hashtags right here so that you understand this is a dilation of the original blue square. All right, let's work through some examples together of how to actually make a dilation. Example number 1 says to find the coordinates of A at 6, 12 for a dilation with a scale factor of 2/3. So 2/3 is a fraction, so it's going to be smaller. Let's look at the x and y coordinates. X is 6. So here we have 6. If you want to make that a fraction, because 2/3 is a fraction, we can put that at 6 over 1, multiply it times 2/3, the scale factor. 6 times 2 is 12, 1 times 3 is 3, and then 12 divided by 3 is 4. So our new x coordinate is going to be 4. Looking at the y coordinate, which is 12. 12 times 2/3, 12 times 2 is 24. This 1 times 3 is 3, and then 24 divided by 3 is 8. So we have a new y coordinate, which is 8. So our new ordered pair, or our new coordinate, is 4, 8. Example number 2. Find the coordinates of image D at -5, +3 for a dilation with a scale factor of 3. Now you have a negative x, so you're going to have to remember your rules for multiplying by negatives. Our scale factor is 3, so we're going to multiply the x value and the y value by 3, starting with x. -5 times 3 is -15. So the new x value is -15. Looking at the y. The y value is 3. Multiplying that times the scale factor of 3 equals 9. So the new y coordinate is going to be 9. So the new ordered pair or coordinates for D is -15, +9. All right, let's continue to look at some examples. By practicing a few. This says that triangle ABC has vertices A at 2, 4, B at 4, 12, and C at 6, 8. And it wants you to find the coordinates of its image for a dilation with a scale factor of half. All right. So we simply take the x and y's. We have a 2 for our x value, for a. We'll call this a. We're going to multiply 2 times 1/2, and 2 times 1/2 equals 1. And we're going to multiply the y 4 times 1/2, and that's going to equal 2. So the new a is going to be 1, 2. All right. Let me grab another marker. The b is originally at 4. The x is at 4. We multiply that times 1/2, and that becomes 2. The y was 12. Multiply 12 times the half, and that equals 6. So you have your new ordered pairs for b with the hashtag to identify the dilation is going to be x is 2 and y is 6. And then our third vertice, which is letter C, which is at 6, is the x value. So we multiply that times 1/2. 6 times 1/2 is 3. And then we have 8 for the y value. 8 times 1/2 is 4. So your new vertices for 4 is at, or I'm sorry, your new ordered pair is at 3, 4. These are the coordinates of its image, of the dilated image. It will be the same shape, but not the same size. It's actually going to be smaller because the scale factor was 1/2. All right, 2 more practice problems I'd like you to look at. Sorry, this practice says to graph triangle STU with vertices at 3, 0, 0, 2, 4, 4. Then it wants you to graph the image of triangle STU with a scale factor of 2. So we're going to dilate it. Let's start by graphing the original STU at 3, 0, 1, 2, 3, and then we don't go up, that's 3, 0. 0, 2, we start at 0, we don't go right or left, we go up 2. And then we have 4, 4. So we go over 4, 1, 2, 3, 4, and we go up 1, 2, 3, 4. And we can connect those, and it looks something like that. All right, now we're going to dilate it using, just like we just did, using the vertices. For S, we had 3 for the x value. We multiply that times 2, and that equals 6. Of course, the y was 0. Anything times 0 is 0. So the new point for S is going to be at 6, 0. So we go 1, 2, 3, 4, 5, 6, 0. Then let's look at 2 is at 0, 2. So the x value is 0. We multiply that times 2, and we get 0. The y value is 2. We multiply 2 times 2, and we get 4. So the new ordered pair is at 0, 4. So we go 0, and we go up 1, 2, 3, 4. And then our last vertice is at 4, 4. So the x value is 4. We multiply that times our scale factor of 2. 4 times 2 is 8. We also have a y value, which is also 4. And then again, 4 times 2 equals 8. So our new ordered pair is at 8, 8. So we can go 1, 2, 3, 4, 5, 6, 7, 8, and count up. 1, 2, 3, 4, 5, 6, 7, 8. Connect those. And we have now created a dilation using the ordered pairs and multiplying by the scale factor of 2. Okay, one last example. Okay, this last practice problem says to dilate the figure by a scale factor of 0.25, which is 1/4, with P as the center of dilation. Okay, P is the center of dilation. We're going to call this P. Should have already had that on there for you actually. This is PQRS. Okay, I've identified the original figure as PQRS, and we're going to use P as the center of dilation. That means it's going to get larger or smaller from this point right here. What we're going to do is we need to know the measurements of the side. We don't have this on a grid, but we've identified the measurement. This P to Q is 8 units. Q to R is 6. R to S is also 6. And then P to S is 10. Okay, so what we're going to do, we have a scale factor of 0.2. If PQ, that's a Q, if PQ is 8 units, we're going to multiply that times 0.25. And 8 times 0.25 is going to be 2. So our new unit is going to be, or our new measurement is going to be 2, right here. Now we also have QR. QR is 6, and we're going to multiply 6 times 0.25, and that's going to be 1.5 or 1.50, 1.5. Now we're just kind of eyeballing it here, but here would be about 1.5. If this is 2, I could call that 1.5. It's a quarter of this one. Same thing with RS. If RS is equal to 6, multiply that times 0.25, and we get 1.5 as well. All right, it's going to come straight down here. And then this last one, which was the original PS, was 10 units. And we multiplied 10 times 0.25. And 10 times 0.25 is going to be 2.5. And that's going to be 2.5 units there. This one would be our new ordered, or our new figure based on a dilation of 0.25. And it's all been dilated from point P, which means it comes back to point P. This is our new shape.